Hello everyone, welcome to the video on Mathematics 8 2.2.4. Today we're going to talk about the modeling using linear relations. Before we start the lesson, there are some things that you should know how to do. You should know how to write an equation for a given sentence, which means we're modeling a situation using an equation, such as the cost is $5 plus $3 per hour. And also you should know how to plot an equation, a linear equation onto the graph. For example, you need to know how to plot a y equals x plus 1. By the end of this video, you will be able to represent real-life linear situations using tables, graphs, and algebraic equations. Let's try the first question. A restaurant sells a small pizza for $10 plus $2 for each topping. Create a table of values and plot the graph. So when we start, the first thing we need to do is we need to identify what the variables are. The variables are the things that are changing in this question. Well, let's think about it. A small pizza for $10. Well, the $10, that price doesn't change. And the $2 per each topping, that also doesn't change. What does change, however, is the number of toppings. They do change. And also the total price will change. So let's declare those variables. I think we can say that let x be the number of toppings. And another thing that is changing is the total cost. So let's use y be the total price. So after we declare those two variables, notice that this time we're using two variables instead of one variable. Now let's set up the table. So because the x is a number of toppings, let's put it on the left-hand side. Number of toppings as the left columns, and also the total price as the right column. And let's think of maybe like 5 points here. So let's first start with, what if you have 0 toppings? Well, as you can see, as you can understand, it's $10 plus $2 for each topping. So I think when there's 0 toppings, the price is $10. What about if you have 1 topping? Well, because it says $2 for each topping, if you add 1 topping, the total price will be $12. And if I add 2 toppings, 14, 3 toppings, 16, and 4 toppings, 18, and so on. Now, using the table, we can sketch the graph of it. Let's look at the numbers carefully. The number of toppings goes from 0 to 4, so which means I can represent each tick to be 1 topping. So starting from 0, 1, 2, 3, and 4 for the number of toppings. And for the total price, the numbers go from 10 to 18. So if I go 1, 2, 3, well, I can't go all the way to 18, right? So let's try to go up by 2, perhaps. So that's going to be 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Like that. And now let's start plotting the points. The first one is a 0, 10, which means I go 0 steps left and right and 10 steps up. So the first point is right here. And second, when you have 1 topping, the total price is $12, 1 to the right, 12 up, and 2, 14, 3, 8, 16, 4, 18, and that's all the points that we have. If you want to, you can put a line through it to show that it's a linear relation as well. Now let's annotate the process. So first thing that we did was we identify the variables. In this case, we identify the variables by noticing the things that are changing. The variables are the measurements that are changing. So in this case, the things that were changing were the number of toppings and the total price. After that, we declared the variables. Afterwards, we made a table of values. And we made a table of values using the given prompt. And afterwards, I made a graph of it using a table. And label the axis. And notice that I didn't label the vertical axis here, which is the total price. Let's try the second question. A bathtub is being filled with water. After 2 minutes, there are 64 liters of water in the tub, and after 5 minutes, there are 160 liters. Write an equation that represents the amount of water in terms of time. So this is a slightly more difficult question because we need to make an equation from the given context. Well, it's hard to see it right away, so why don't we start by making a table of values. In order to make a table of values, we first need to declare the variable. In order to declare the variable, we need to first identify the variables. Well, in this case, what are the things that are changing? Well, I think, because it says after 2 minutes, the liters of water is 64, 5 minutes, 160 liters, so I think we can easily tell that the time, the number of minutes is changing, and also the amount of water in liters are changing. So let's declare the variables as let x be the time in minutes. And let's also say that let y be the amount of water. In liters. Now let's make a table. So we have the time as the left column and the water as the right column. And the two points that we know is that after 2 minutes, is 64 liters of water. So that means after 2 minutes, 64 liters of water. And then another thing that we know is that after 5 minutes, there are 160 liters. Notice that I intentionally left out some space here. Well, now let's think about it. If there were 2 minutes, 64 liters, and 5 minutes, 160 liters, can we guess how much water would I have at 3 minutes mark, and a 4 minute mark, maybe in 1 minute mark? So let's try to fill up the gap here. Well, I know that between 2 minutes and 5 minutes, there are a 3 minutes gap. Now what about 64 and 160? Well, from what I know, I think the difference would be 96. So in 96 liters of water have been filled in that 3 minute gap. Or in other words, every minute it increased by 96 divided by 3, 32 liters. So we can guess, by 3 minute mark, 32 liters of water have been accumulated, which goes up to 96 here. Another 32, it would be 128, and then another 32, 160. If you go backwards, we can do the same thing. From 2 minutes, 64 liters, we go back in 1 minute, it would have been 32 liters. And also we can go back one more step if you want and say at 0 minutes, we had 0 water, but obviously in the bathtub. So now we filled up the table. Do we think we can use this scenario to make an equation? Well, I think the pattern is quite clear. Every minute, 32 liters of water are being filled. So that means 1 minute, 32, 2, 64, 3, 96, 4, 128, 5, 160. I think the relationship is quite clear. I think we can say that the amount of water, y, represented as a variable y, is 32. The 32 is the 32 liters per minute being filled times the time in minutes, x. So that is my final equation. Let's annotate the process here. Once again, we first start by identifying the variables. And then we do the declaration of the variable, declare the variable. And then we made a table, make a table of values. And in this case, what we did was we looked at the pattern of the table to fill in the gap, to find more points than the ones that we have. And after we filled in the gap, we realized that, hey, every minute, 32 liters of water are being filled, so we make an equation. That connects two variables. So what we realize is that the time variable and the water variable are actually connected to each other in one equation. So in today's lesson, we talked about the linear relations. The linear relation is relation of two variables that we connected and we represented. And on the equation, it looks like a very simple, something times something, y equals ax or y equals 32x or so. On the table of values, it shows that each increment is going up or going down by the same amount per every step. And also we can see it visually, graphically, that the points are aligned in a single straight line-like patterns. Also, it's very important that we know about the variables. The variable is that the measurements that are changing within the situation. So knowing what the variables are in the word problem will help us solve the problems in this section. Thank you for tuning in this video, and I'll see you in the next one.